Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the multiple choice question based on chapter number 2 according to the new revised syllabus implemented from academic year 2021-22 this year, but here discussing as a reactive methylene compounds object multiple choice questions or the objective type question as per the new revised syllabus. So let's see here what is ethyl acetoacetate undergoes acid hydrolysis with dilute HCl to form dash dash, and the options are given: acetoacetic acid, ethyl acetoacetate, ethyl acetate, methyl acetate. These are the, and as we know that ethyl acetoacetate, structure of ethyl acetoacetate is this one, CH3 C double bond O, then CH2 C double bond O OET. This will be the acetoacetic ester, or you can refer as ethyl acetoacetate. Now here acetoacetic acid means here CH3 C double bond O, CH2 C double bond O OH. This will be the structure of acetoacetic acid. Ethyl acetoacetate is the structure of ethyl acetoacetate. Ethyl acetate is here CH3 C double bond O, then OET. This is the structure of ethyl acetate. It's a ethyl, and this part is generally termed as acetate. This is a acetate, right? C double bond OET, ester is known as acetate. C double bond O. So this is ethyl acetate. C double bond O CH3. This group is known as acetate. Now methyl acetate. Instead of ethyl, there will be this one, C double bond O, Me. Me is nothing but, we know that Me is nothing but as this methyl group. And Et, these are the acronym or the short form generally used in the organic chemistry, CH2 and the CH3, methyl and the ethyl. So here ethyl acetoacetate undergoes acid hydrolysis with a dilute HCl to form what it forms. Just as a hydrolysis process, what it can do when the reaction is carried out with dilute HCl, the ester group get transformed into acid, that the changes occur. You would get here CH3 C double bond O, CH2 C double bond O, and ester group transform into as acid, and the name of this compound is acetoacetic acid. So A is the right answer, correct answer for this question. Now let us move on to the next question. Next question would be question number 28. And what is it? Question number 28 would be base catalyzed condensation. Base catalyzed condensation. Base catalyzed condensation. Base catalyzed condensation of two to form to form an alcohol and beta ketoester, an alcohol and beta ketoester is called dash, and the options are as such: aldol condensation, aldol condensation, aldol condensation, aldol condensation, aldol condensation. Second one, Claisen condensation. B, Claisen condensation, Claisen condensation. C, transesterification, and D, Canizarose reaction, reaction. These are the different answers are given. Let's read the question carefully. Base catalyzed condensation of 2 to form an alcohol and beta ketoester. These two means one is alcohol and another one is a beta ketoester, is called dash. In aldol condensation reaction, as we know that beta hydroxy groups are there. Claisen condensation reaction, where we will get beta ketoester, and C is a transesterification, Canizarose reaction. In Canizarose reaction, generally take place between two moles of or molecules of aldehyde which does not contain alpha hydrogen atom, and that kind of the compound or the molecule undergoes Canizarose reaction, where oxidation reduction reaction takes place. Means one molecule goes in one molecule obtained in oxidized form and another molecule is obtained in a reduced form. One means that is a redox reaction, oxidation and the reduction reaction takes place. That reaction is known as a Canizarose reaction. Aldol condensation reaction can take place between two molecules of carbonyl group, but one of the molecule must contain alpha hydrogen atom, then and then that undergoes aldol condensation reaction, and the resulting compound obtained would be beta hydroxy aldol and Claisen ester condensation. So this is generally known as a Claisen condensation reaction, where we can get alcohol and the beta keto ester after this one. Now question number 29. Let me write it down first and then we will find out the correct answer from it. Ethyl acetate on heating. Ethyl acetate on heating with sodium ethoxide gives dash dash dash, where A sodium acetate, B would be ethyl acetoacetate, and C would be ethyl alcohol, and D would be diethyl ether. Now, what do you think? Which would be the correct answer? Ethyl acetate on heating with sodium ethoxide. Ethyl acetate, as we know that CH3, C double bond O, OET, and it will be treated with sodium ethoxide, means NaOET, we can call it as a sodium ethoxide. And this is a well-known reaction, that is a Claisen ester condensation, and it produces the product CH3, C double bond O, CH2, C double bond O, OET. This type of the product we get, and this is known as a ethyl acetoacetate or acetoacetic ester or beta keto ester, and B is the right answer for this question. Let us move on to the next question, that is a question number 30 here. Question number 30. Question number 30 here. Acetoacetic ester, I am writing as a short form, on reaction with methyl bromide, methyl bromide in presence of sodium ethoxide, sodium ethoxide followed by hydrolysis, and decarboxylation, gives hydrolysis form, dash dash. Option A would be methyl N-propyl ketone. Methyl N-propyl ketone. B would be dimethyl ketone. C would be ethyl methyl ketone. And D would be diethyl ketone. Diethyl ketone. Read the question carefully. Here abbreviation I have used here, AAE. Acetoacetic ester on reaction with methyl bromide in presence of sodium ethoxide followed by hydrolysis and decarboxylation gives hydrolysis form, and which is of the following. Now as we know that here first one is the ethyl acetoacetate. Let me draw here CH3 C double bond O, then CH2 C double bond O, OET. Here first it will be reaction with methyl bromide in presence of sodium ethoxide, NaOET. Here methyl bromide, which we can write here CH3Br, followed by hydrolysis, second H2O in presence of H plus, hydrolysis process, third one decarboxylation, just heat it, carbon dioxide get evolved, and the resulting compound of 10 will be this one. What do you get here? Carbanium CH3 will attack over there, and finally you will end up with this CH2 and the CH3. This would be the product, means 2-butanone will be the product form. The common name of this compound we can call it as a ethyl methyl ketone, and C would be the correct answer for this question. Now let us move on to the next question, that is a question number 31. Question number 31. Now what is it? Let us draw those questions. Question number 31. Ethyl acetoacetate reaction with ethyl acetoacetate. I am writing using ethyl aceto. Let me write first. Ethyl acetoacetate. Ethyl acetoacetate on reaction with ethyl acetoacetate on reaction with 2 moles of ethyl bromide. 2 moles of ethyl bromide, 2 moles of ethyl bromide in presence of sodium ethoxide, sodium ethoxide followed by hydrolysis, and decarboxylation gives hydrolysis forms dash and the answer as follows: 3-ethyl 2-pentanone, A 3-ethyl 2-pentanone, B would be methyl isopropyl ketone, ketone, and C would be 3-methyl 2-propyl ketone, 3-methyl 2-propyl butanone, and C would be 2-ethyl 3-pentanone, 2-ethyl 2-pentanone, See here, read the question carefully. Ethyl acetoacetate on reaction with 2 moles of ethyl bromide in presence of sodium ethoxide followed by hydrolysis and decarboxylation gives hydrolysis form. Different product names are given. 3-ethyl 2-pentanone. Do you know the structure of this? ON indicate as a carbonyl groups are there. Pent indicate as a 5 carbon atom in the straight chain. Let me draw here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. At 2 position there will be a carbonyl group. At 3 position there is a ethyl group. Means here CH-2, CH-3 group, and rest of the thing you can fulfill by attaching proper appropriate number of hydrogen atoms. Here CH3. This is the structure of 3-ethyl 2-pentanone. 1, 2, 3 at 3 position ethyl group, and this is the correct IUPAC name of. And methyl isopropyl ketone, methyl isopropyl ketone. Here methyl isopropyl ketone means there is a carbonyl group. Let me draw here CH3 methyl, this one, and here CH, CH3 and this CH3. This is known as Methyl, this is a methyl, and this is a isopropyl group, ketone, and this is a carbonyl group. This would be the structure of methyl isopropyl ketone. 3-methyl 2-propyl butanone. Here 3-methyl 2-propyl butanone, but indicate as a, suppose let us see here, at 2 position there is a carbonyl group, then 1, 2, 3 position there is a methyl group. Here you can write propyl, 2-propyl, this is a group CH3. This is a 3-methyl, 1, 2, 3-methyl 2-propyl means once again here you can write once again CH3, this one. 3-methyl at 2 position propyl group is there. 3-methyl 2-propyl. I think this is called as a this group. 3-methyl 2-propyl butanone. This is the structure. Just this structure is written in another way. And 2-ethyl 2-pentanone. Pent indicate as a 5 carbon atom in the straight chain. At 2 position carbonyl group. Ethyl at 2 position 2-ethyl. Something is 3-pentanone. Here is a 3-pentanone. So 2-ethyl 3-pentanone. Here you can write 3-pentanone means this is not the structure. Let me. Pent indicate as a 5 carbon atom in the straight chain like this. 3 position there is a carbonyl group. 2-ethyl means here CH2 CH3 group. Here CH3 CH2 2-ethyl 1 2 3 1 2 3 4 5 2-ethyl 3-pentanone. Ethyl acetate on reaction with 2 moles of ethyl bromide in presence of sodium ethoxide followed by hydrolysis and decarbonation. Let me draw the structure first. Ethyl acetate. Let's see here. Here ethyl acetate is this one, CH3 C double bond O, then CH2 C double bond O, then OET. It will be reaction with 2 moles of ethyl bromide to this one, CH3 CH2 Br in presence of sodium ethoxide NaOET, followed by hydrolysis H2O in presence of H plus, heat minus CO2 decarboxylation, and finally you will end up with this structure CH3 C double bond O, then CH, then CH3 C double bond O, and here CH2 CH3, another one CH2 and the CH3. This will be the structure. Here 1 2 3 4 5, at here also 1 2 3, at 3 position there will be a ethyl group. So make the correction here. 1 2 3, at 3 position there is a ethyl group. This 3-ethyl 3-pentanone. This would be the correct answer for this question. I think these are the some of the examples we have discussed over here. Still there are some examples still remaining. I think the remaining examples we will discuss in our next lecture. Till then, have a nice day. Thank you.